Hi guys, I'd like to take a look at Handout 128 M2-6 30, Handout 30. It's related to condensing furnace venting guidelines. It's a real small little blip on just doing general venting. To begin with this particular handout, I wanted to specifically just kind of outline and identify the reason why looking at furnace venting and the combustion air piping, how really critical that is for the operation of a Category 4 type appliance. And part of the biggest reason is a lot of times you can attribute back to some of those issues can be traced back to, let's say, if it's a pressure switch problem, it could be related or as a combination with the venting, as well as some other issues, and whether it's with the inducer motor or losing some power or whatever it might be. But specifically, I am trying to just kind of reiterate that how these Category 4 type applications fall directly under the manufacturer's recommendations for sizing, for application, installation, anything like that. You have to thoroughly follow them. So they're the ones who dictate those things. So make sure you are looking at that. Specifically, things that are pertinent with this would be related to like the sizing of the vent pipes and things like that. And I know you guys have probably gone through some of that as well, either whether you've done during the installation process or whatever it might be. So that part I didn't hit up on this particular handout. Most of our applications deal with what we call direct venting, and ideally the beauty of a direct vent system is the fact that you have a dedicated exhaust system as well as a dedicated intake system that generally comes directly from outside. Usually that's what we would associate them. So we discharge outside, we bring it in from outside as well. So we're not using interior air for combustion, and that's typically what we do. Generally, multiple condensing furnaces should not be connected to a common vent system as a general rule. That I've kind of outlined and bolded that in here. I know that there are some applications that will allow a common vented system. It's somewhat rare, and you have to be super careful, because what you don't want to have is it where when one unit runs, it's directly affecting the operation of the other appliance. So that's really our challenge that we normally have on that. So you really have to really follow their rules. If they allow you to do it, then by all means you can do that. So there is one other piece that I wanted to hit up on here. So one of them is the transitions, and this one's almost it's somewhat obvious, but my goodness, I have seen this on installations where an installer would install a transition right directly in the horizontal section. Now the problem is all the condensate just kind of gets and stays right in the little spot. So, and you might think, well, it's just condensate. And at first, I kind of thought that, but then as I saw some of these units in the field that had these, what I noticed what was happening is a lot of that moisture and that condensate that was in their system, what they were doing is they were actually developing mold, and it was collecting debris that would get wet, and then it would stick in that pipe. So it created some other issues. So this is a really big one. So especially when you have a furnace that might leave at 2 inches, but you need to run a 3-inch pipe, you definitely want to make sure that you do this. So this is definitely one that you want to be watching. So very good. So looking at some of the other types of applications, this is one that we don't normally look at a lot of short 5 to 8 foot vent systems, but I just want to hit this up a little bit. Is some of the manufacturers will have some guidelines. If you have a really short system, maybe a furnace is located right near an outside wall, and I would probably say this is maybe more likely to be seen on a commercial application than it is on a residential system, but In a system like this one, there are some guidelines of what they want for horizontal and so on and so forth. You just kind of just follow those guidelines. All right. This one is just a little blip, and I wanted to point this out specifically for your terminations. And one thing that I noticed that I did not see very good references in as far as terminating the combustion air and the vent pipes would be things like, let's say, and I guess I've seen this, whether it's the USA or the Canada version of it. Canada has some slightly different rules, and obviously we have to follow the USA one for work here. But things that are typical, that are specified out of this particular manufacturer that I grabbed the data out of and this chart out of. And one thing in particular that I've noticed here is, for example, like they talked about, grade above and anticipated snow level. And this one I mentioned here, typically a foot is pretty typical, but you'll notice in the Canadian one, they'll list 18 inches above a roof surface for those things. So you just kind of watch that. A dryer vent, again, to always look at the table that they specify in there. Typically, dryer vents are going to be about 3 feet. A plumbing stack would be the same thing, about 3 feet. A mechanical air, fresh air intake, about 10 feet typically. And that's pretty common in our industry. Again, just really look at the specific table or the code of what they are specifying. And this one is from an older unit, so it's certainly possible that things might have gotten updated a little bit on some of these, or they might have made it more stringent. So the other one, as far as this one, it talks about, for furnaces with an input capacity less than 100,000 BTUs for a non-mechanical air supply. And they talk about windows and doors which can be open. They have, there's a certain amount of air or a certain amount of space distance that you have to maintain away from those. So typically I try not to have any type of vent intake or exhaust pipe that's near an operable window if I can help it at all. Especially just because you don't want to have it where that person could open up that window and you're venting those exhaust gases out, and right away those gases are kind of filtering back into that building. So that's the reason for that application on there. So you just have to kind of watch that. This one here that I've highlighted in green, put a little asterisk next to that. That one is from a service regulator vent. So this might be a vent from a gas regulator, an electric meter, gas meters, any other type of relief equipment. They want to have at a minimum of 4 feet horizontal distance away from those. So that means you cannot terminate a furnace next to or near those units that are anything within 4 feet horizontally. So when you look at some of the code books, they will have some pictures that might identify some of those just slightly different, but generally it's about 4 feet. So you really have to watch that. And again, anytime you're picking your location, it's really things that you have to do. And then of course above the grade when adjacent to a public walkway, oftentimes that's 7 feet. And part of the reason I think for that is they really want to make sure that guys are not allowing the condensate that would come out of those systems that would maybe fall on the ground or floor and create a really slippery surface. And I think that's the one of the bigger reasons why that is. So that's kind of a big one on there. I also want to point out this note number 2 that's down in here. And they talk about when locating the combustion or the vent terminations, consideration must be given to the prevailing winds, the location, other conditions which may cause recirculation of the flue products. And the recirculation of flue products in the adjacent vents, what that can really create a problem for you. In fact, I've seen units where there has been significant damage to the electronics. heat exchangers, gas valves, where you've had some of the discharge gases kind of recirculating and going right back into the return or the inlet of the combustion air pipe. And that's one of the big things that you really have to watch. So usually this is a really big problem on multi-stage or modulating equipment. So usually on those you really have to make sure you have a bigger, a longer discharge or separation. I'm going to show you an image coming up shortly that might address some of that as to maybe an idea, a possible idea on how to handle that. All right. And let's take a look at some of these. So there's just a few little terminations that I just wanted to hit up on a little bit. Is there are, with venting off the discharge pipe, and probably one of the biggest things that they typically will do is they really want to make sure that a furnace pipe will discharge and pull its combustion air from the same pressure zone. And you'll notice on here they list an 18-inch maximum distance between those two pipes. So they don't want a significant distance on them. There might be a couple of reasons for that. I think also the separation, the vertical separation is also another area that you want to kind of take a look at though as well. And then when you're on a roof, you really have to watch the snow level, because the snow level builds up, and if you don't have enough pipe coming out of there, that could actually get blocked off on there. So you want to be a little bit careful on that as well. Some of the people also use a concentric vent. And the concentric vent is really nice for the sake that if you are venting a pipe out the outside, you really only need one penetration. And they really work well, but they need to be installed properly as well. And that's a typical way that they do it. And there's things like how much separation do you want between, let's say on this one, between the building and the combustion air intake and the discharge. I've even had to do this on jobs where I've used a concentric on a multi-stage modulating piece of equipment, and I've actually had to extend this pipe out further. And the reason why I had to do that was I had to get those products of combustion away from the intake, where some of that air on one of the applications was coming right out of here and going right back into and getting drawn into the intake. So by creating that separation, that was helping me. And this was on a horizontal application. I would say for some of the modulating equipment, I would tell you that it's also going to be an issue here as well. And this is typical. What you might have to do is you might have to actually extend that pipe further out for that. So you just really watch that a little bit on that. This picture here, figure 33, I wanted to hit up on a little bit. And that one, there's a couple of things that I did. And this is probably really between figure 33 and 34 on those applications. I think those are typical to our systems in let's say in the winter areas around by the northeast Wisconsin area, and in specifically in northern climates where you start having snow issues. I think one of the big things is having that minimum separation between the intake and exhaust. The other thing that I wanted to point out is on this one here, this is something you may have to do on these, especially on multi-stage, and is what I've drawn here. And what I drew here was a vent elbow with that's shown here with an extension pipe that might be extending beyond the building, maybe 18 inches or so. And then what happens also is some of the contractors in that horizontal run, they will go from, maybe they use 1.5 inches or 2 inches coming out of the building, and then right at the exhaust they will make it a smaller pipe, and they will reduce it maybe to 1.5 inch pipe. And they do it to increase the velocity so that those gases get carried further away from the building. And so this is really, I would say this is a really big one for any type of modulating equipment. I really don't expect to see a lot of that issue with non-modulating equipment, but again, really follow the manufacturer's recommendations so that you are doing what is necessary. All right. So, and there's a couple of them here. When you start getting multiple furnaces and things like that, how do you prevent the gases from going from one unit to the other one? And again, watch the separation, those types of things on there. Same thing goes on here. The intakes, here it's not really a big deal between those, but this one and this one is certainly a bigger issue to contend with. So that's that's a good one on there. So that's really very typical of most of ours. So in the last page here, I want to specifically hit up on the removal of existing furnaces from a common vent system. And what happens is I would say this is probably a bigger deal in areas where you've got maybe some older homes that had maybe a furnace that was changed over from a mid-efficiency to a high-efficiency appliance, and then you're left with a water heater that has to get vented in a larger vent system. Or maybe you had a customer that had a boiler that they had changed out, and something changed where they said, we're going to go to a high-efficiency boiler, and then that eliminated one of the big BTU numbers for those appliances. So you really have to watch this carefully. But I put a few notes on here, saying that if you had a furnace that was being replaced from a common vent with other appliances, make sure you check the operation of the other common vent. So, for example, the furnace you're removing or the appliance you're removing, you had to seal those unused openings, which would be fairly obvious. Inspect the existing vent system. Is it sized properly? Are there any deficiencies where you would say, we really, we got away with it for a while, but now we really need to correct this issue. You're really taking a liability to make sure you're not creating an unsafe situation for your customer, since you would be held liable if there's problems that were not identified and you should have identified them. So you really want to look at the integrity of the system. So this one on item number 3, that's a little bit tougher to do, and I think that takes a little bit of time to really do, so it's a little more challenging. But they talk about being, as far as being so practical as, to close all the building doors and windows and those types of things that would be either drawing air or supplying air into the space. And, they talk about turning on the clothes dryer and other appliance exhausts, like your bathroom exhaust fans, things like that, and operating them at maximum capacity. And what they're doing, and closed fireplace dampers, what they're doing is they're saying they want you to do this to make sure that when you light those appliances off, are they actually venting? And it really kind of ties in what you're doing here is really tying into kind of what's going on here. And they talk about testing for spillage. Now, spillage was one of those that I talked about in one of the PowerPoint YouTube videos. And so when we test the system for spillage, we're going to run that on a draft hood appliance after 5 minutes. We need to make sure that are the burners running? Is it, you'd expect that. Is it venting correctly? Use a match, use a candle. They make smoke testers that would allow you to see a puff of smoke, but a simple match works great, and just watch that smoke. And then, of course, if you've determined that the appliance remaining to that vent system that we've described a little bit, if everything is working, then you should be pretty good, and it shouldn't be a big deal. Watch the codes. Some of the codes will require, hey, you cannot. They might say you cannot use this system. You're going to need to make sure that because you're pulling this bigger appliance, and maybe that common vent is larger, and whether it's sized correctly or not, they may force you by code. They may say you have to put in a chimney liner or a vent liner, or you may have to do something different. So you want to probably check with the foreman on the job to determine if that's a requirement or if it's necessary based on the local codes. Item number 7, if you've observed, if improper venting is observed during any of those tests, correct the vent system. Maybe you have to look for, maybe I got to resize it. Maybe I got to do something. Try to investigate further to make sure that you are, that it's working, you can get it to work correctly. There's a number of corrective measures that you may have to do, but it's things that you have to do. Venting is such a major deal when you're talking about pulling older existing appliances that provided some heat into the vent system, and now I have that one smaller appliance, and now it doesn't want to vent. And it's such a safety issue, because if you are wrong and that appliance starts to vent within that building because it's not venting outside because of the lack of draft due to maybe an oversized vent system or whatever it might be, you're creating an incredible liability issue for you and your company. So anyway, so that's just a little bit of a thought on essentially condensing furnace